In today's lesson, we're going to be talking about implicit differentiation. This differs from how we've been doing derivatives in the past, where we've had our derivatives expressed explicitly. For an example, let's just say we had the derivative of the square root of 1 minus x squared. The derivative of this problem is just equal to negative x divided by square root of 1 minus x squared. We could go through the whole process, but more importantly, I want you to see that we have a d dx equal to something. This d dx kind of acts like our y variable, and this is defined explicitly because y equals x. Now, the same problem could be defined implicitly as x squared plus y squared is equal to 1. If you were to give a student this problem and tell them to find dy dx, in other words, the derivative, this would seem a lot more complex. How do we do that? We have this y variable here, which isn't the same as the x variable. How do we derive for that? And that's a good question, and that's what we're going to be solving today with implicit differentiation. Let's actually work this example out. So our example was x squared plus y squared is equal to 1, and we want to find dy dx. What is this equal to? Well, we can find most of this just by deriving normally like we've been doing in the past few lessons. So to start, we can just find the derivative of x squared. This is just power rule, so we bring this 2 down to the front and subtract 1 from the power. So this is 2x, and we can actually do the same thing for the y variable as well. We bring this 2 down to the front, subtract 1 from the power. So this is equal to 2y. But since we have a y variable here when we're trying to derive with respect to x, we have to tack on a dy dx. The reason we do that is because we're deriving for the y variable, and after all, we do need to find dy dx, not d dx, so we need to tack this on here. And this is equal to the derivative of 1, and the derivative of any constant is just 0. So now this problem is just a simple matter of isolating dy dx, and that's pretty easy. We've been doing this since algebra 1. Here we just subtract 2x, so now this is equal to 2y dy dx is equal to negative 2x. In order to isolate for the dy dx, we just have to divide by 2y on both sides. So dy dx is now just equal to negative x divided by y. This negative 2 and 2 cancel out to just be negative 1, so that's why that's negative x over y and not negative 2x divided by 2y. And that is the derivative we were looking for. We found this derivative implicitly. In other words, we have two variables on one side instead of one variable defining the other. Remember, in an explicitly defined problem, d dx or f prime of x kind of acts like y. It's sort of the same thing, but in this case, we have the y variable within our problem. So that's the only difference here. We're only going to do one more example for this video, and then at the end I'm going to link another video with a lot more implicit differentiation examples because they're great and I don't want to just copy his video. So in this example, we need to find the derivative. X cubed plus y cubed is equal to 6xy. This is a little bit more complex, but mostly keeps the same strategies as before. So since we have the y variable within our equation, we do need to find dy dx. So let's find dy dx for both sides of this equation. Let's find it for both sides. Let's start with the left side. Just like before, we can just use the power rule to find the derivative of x cubed. So we bring our 3 down to the front times x. 3 minus 1 is 2, so our new power is 2. So the derivative is 3x squared. We do the same thing for y. We bring this 3 down to the front and subtract 1. So this is now 3y squared, but because there's a y variable here, we do have to multiply by dy dx. Now on the right side, we actually have to use the product rule. We have one function being multiplied by another, and because they're different variables, we have to use the product rule. Just as a refresher, the product rule is f prime of x times g of x plus f of x times g prime of x. So function number 1, or f of x, is going to be 6x, and function number 2, or g of x, will just be y. So first of all, f prime of x is just the derivative of our first function, which is 6x. The derivative of 6x is just 6, and now we need to multiply that by g of x, which is just y. So this turns into 6y. Now let's do the same thing, except we multiply it by g prime of x. F of x is just 6 of x, so let's add 6x, and then multiply that by g prime of x, which is just y. The derivative of any variable that doesn't have a power on it is just whatever the coefficient is. And in this case, the coefficient of y is just 1. And since we just found the derivative of a function with a y variable in it, we need to multiply that by dy dx. So this is just 1 times dy dx. So I'm just going to write it as dy dx because 1 times dy dx is just dy dx. Once again, we just need to isolate for dy dx. So let's take the two functions that have dy dx in them and put them on the same side. So first let's subtract 6y. And in order to isolate for dy dx, we're just going to subtract 3y squared dy dx. So this problem now turns into 3x squared minus 6y is equal to negative 3y squared dy dx plus 6x dy dx. And now we have the variables isolated on their respective sides. But since these two do have a common factor of dy dx, I'm going to change this from this into dy dx times negative 3y squared plus 6x. We just factored out the dy dx and multiplied it within the parentheses instead. It's the same thing. And of course, to isolate for dy dx, we just had to divide all of this by negative 3y squared plus 6x. And we'll do the same thing on the other side. So dy dx now equals 3x squared minus 6y divided by negative 3y squared plus 6x. And that is the derivative of our implicitly derived function. Like I said earlier in this video, I want to link you to this video because it has many great examples. But if you'd like to move on to different Calculus 1 lessons, consider checking out my playlist here and consider subscribing if this video was helpful for you. I'll see you guys in the next lesson.